For billions of years, the sun's hydrogen fuel has generated clean power for Earth in the form of sunlight. Soon, hydrogen will be supplying many of our needs for electricity, transportation, and industrial power.
To me, it makes sense for us to choose hydrogen and fuel cells to do that. You get water vapor coming out of the tailpipe, you have twice the efficiency of power to the wheel of the vehicle, plus hydrogen is everywhere.
Hydrogen is denoted by the letter H in chemical formulas. For use as a fuel in its most stable form, hydrogen consists of two atoms and is commonly known as H2. Hydrogen is abundant on the Earth, but it is almost always combined with other elements, usually with carbon or oxygen. Fossil fuels like coal, oil, and natural gas contain atoms of hydrogen combined with atoms of carbon. Plants contain these atoms as well. These materials that contain hydrogen and carbon are called hydrocarbons and represent a source of hydrogen. Water, another important source of hydrogen, is composed of two atoms of hydrogen and one atom of oxygen. It is represented by H2O. A sustainable hydrogen economy depends on several factors. 1. Low-cost dependable methods for making hydrogen and improved methods for storing and transporting hydrogen. 2. Cost-effective technologies that utilize hydrogen for producing electricity in industry and as a fuel for transportation. 3. Public acceptance and support for the use of hydrogen. It took time to make the change from horses to automobiles, and it will take time to reduce our dependence on foreign oil and move to hydrogen from a wide variety of sources. And North Dakota is helping to lead the way.
Not only our nation, but the entire world is going to continue to need more energy, and we want that to be dependable. We want it to be as inexpensive as possible, and hydrogen is already starting to be and is going to continue to be one of those sources of energy that we use to meet our needs.
To access this energy resource, we need to release the hydrogen contained in biomass, fossil fuels, and water. The National Center for Hydrogen Technology is continuing a tradition of more than 50 years of hydrogen research at the Energy and Environmental Research Center at the University of North Dakota. Researchers at EERC's NCHT are evaluating a number of technologies that have the promise to convert the hydrocarbons in plants and fossil fuels into usable hydrogen fuel.
We are bringing a great deal of expertise and wisdom, in a sense, and also something that's phenomenally important. We work constantly with corporate partners who bring a very real-world, market-driven aspect to everything we do. So I think we're playing a fundamental cornerstone role in the future of hydrogen development in this country.
Currently, we can produce hydrogen from hydrocarbons like biomass and fossil fuels in several ways. Hydrogen is released when the hydrocarbons are partially burned in a process called gasification. This process is currently used at the Great Plains Synfuels facility near Beulah, North Dakota, to make synthetic natural gas from lignite coal. Gasification is also the process that will be used in FutureGen, the U.S. Department of Energy's concept for emission-free coal-fired electrical generation. FutureGen will make hydrogen from coal. This hydrogen will fuel turbines that generate electricity and provide fuel for vehicles. Emissions will be captured and injected underground to help boost oil production. Electricity can be used to weaken the chemical bonds between oxygen and hydrogen in water to release the hydrogen gas. This process, called electrolysis, makes high-purity hydrogen. Renewable energy from wind in North Dakota is one of the possible sources of electricity for this process. Basin Electric Power Cooperative is working with the EERC and other partners to demonstrate the use of renewable wind resources to make hydrogen from water by electrolysis.
The role of hydrogen will play a major part in the long-term future of energy in this country. And I say that because today there's a stronger and stronger emphasis put on decreasing our energy dependency upon foreign sources of fuel.
Improved methods of transporting and storing hydrogen are needed. Even at high pressures, hydrogen takes up a large space. Several solutions are being developed to ensure adequate hydrogen is available. These include high-pressure storage methods, storing hydrogen bound by other compounds and releasing as needed, making hydrogen as needed on demand from more easily stored feedstocks, using natural gas and liquid fuels as hydrogen carriers. For the hydrogen economy to become a reality, we will need many fuel dispensing stations across the country, much like current gasoline stations. The continuing research at the EERC will help make this happen. For the hydrogen economy to become reality, millions of vehicles in the U.S. will have to switch to this clean fuel. That change is starting today. With some simple changes to the engine control system and a certified hydrogen fuel tank, today's internal combustion engine vehicles can be modified to use hydrogen instead of gasoline. Fuel cells directly convert hydrogen to electricity by chemical reactions. Because the fuel is not burned, no harmful emissions are produced. Fuel cells are currently being tested in a variety of vehicles around the world. As an example of this, the EERC, E-Power Synergies Incorporated, and Resurface were instrumental in developing the first commercially available fuel cell ice refinisher.
We really need to pole vault to a new point here, and that point should be production, storage, and transportation capabilities for hydrogen and fuel cells so that we can use them routinely and develop the infrastructure to use them in our country's vehicle fleet.
Even if hydrogen is available and hydrogen fuel technologies are on the market, consumers will still need to make the choice. To learn more about hydrogen and the National Center for Hydrogen Technology's full range of hydrogen programs and outreach activities, visit the EERC website at www.undeerc.org.
Funding provided by the U.S. Department of Energy, the North Dakota Division of Community Services, and the members of Prairie Public.